look at how we can use some real-life examples or use direct variation to solve some real-life examples. It says the income at a store varies directly. There's that phrase we're looking for. Varies directly as the advertising budget. Okay, so income varies directly to advertising budget. When the owners spent $3,000 per month to advertise, their monthly gross income was $120,000. If the owners increased their advertising budget to $5,000 per month, how much gross monthly income can they expect? Okay, so we're focusing on varies directly. When we do that, we think of this equation, our direct variation equation. Okay, so what that means is they advertise $3,000 per month. What their result would be is $120,000. So think of this almost in terms of like inputting and outputting. If they're inputting $300,000 here for X, okay, that's their advertising budget, then they're getting out $120,000. And what we've got to figure out is what our constant of variation is. Okay, again, they vary directly. This $120,000 is dependent on this $3,000. So if we're spending $3,000, we're getting a result, or we're getting an output of $120,000. Okay, so again, X is your input, Y is your output, varying directly. So if I solve this for K, I end up with K equals 40. So our constant of variation is 40. So remember, again, when we do that, all we do is plug in our K back right into our direct variation equation. But now it asks us, what happens if the owners increase their advertising budget to $5,000? Well, we have our formula. The money, the income, is going to be equal to 40 times whatever our advertising budget is. So if we increase from 3,000 to 5,000, now we can just plug that in for X and say Y equals 40 times 5,000, and we get 200,000 if we multiply those together. That doesn't mean for sure we're going to get 2,000, okay? But if it's asking how much gross monthly income we can expect, this is what we would expect. Okay? If we have this constant of variation, if truly our Y here is always going to be 40 times whatever X is, and that was from the original information they gave us. Okay? So use the formula to find out what your constant variation is, and then you can change your independent variable, you can change your X to figure out how much income in this case you can make. Let's look at another little example. This is important because we want to relate ratios to this. Okay? Now it says the forearm lengths and body heights in inches of 5 people are shown below. Okay, so F obviously is forearm, body is B. So if our forearm is 7 inches, then they're saying you're 52.5 inches tall. And this is just from 5 people. It says write a direct variation model that relates body length B to forearm length F. So our normal direct variation model is Y equals K times X, varying directly. Okay? As X changes, Y is going to change based on this constant. But they don't want Y and X, they want body length B to forearm length. So if you think about this, they're relating body length to forearm length. We can say that we can take some constant, we don't know what that is yet, but multiply it by our forearm length, and that will give us our body length. Okay, now look here at this equation. Body length equals K times F, our constant times our forearm length. Another way we can figure out what K is, just like we practiced solving for X and Y before, is to solve for K here. Okay, again, this is not necessarily something you have to do, but it does become kind of helpful. That means our constant is going to be equal to whatever the body length is over our forearm length. It's going to be equal to this ratio. So what we can do when we're given multiple pieces of information, instead of having to solve 5 equations, we can write 5 ratios and take the average. Okay, so here what we're going to do is we're going to add something to this column here, and we're going to find the ratios. So what I'm going to do is I'm going to just divide body length by forearm length. So if I do that, if I go 52.5 divided by 7.0, I get 7.5. I'm going to do the same thing here. 55.5 divided by 7.5. Okay, keep in mind, guys, we're trying to figure out what this k is. Everything we've done so far, we're trying to figure out the constant of variation. So if I take 55.5 and divide it by 7.5, we get 7.4. Let's look at this person. 58.4 divided by 8 is 7.3. 63.5 divided by 8.5. And this one's approximately equal to 7.5. And one more, 68.4 divided by 9 is 7.6. Now, you honestly just kind of look at this and kind of come up with an average. You could add them all up and divide by 5. Okay, but just looking at this, I can kind of see, and that's probably the best thing to do is add them all up and divide by 5. But looking at this, we have a couple that are 7.5, you know, a couple that are lower, a couple that are higher than 7.5. I'm just going to go with my constant is 7.5. Now, again, why did I do that? Where did it come from? I set up my direct variation model, okay, but in this case I solved for my constant. I said you take your body length and divide it by your forearm length and you get your constant of variation. Now it's not exact, but it's pretty close. So now when we want to write a direct variation model, I can just say here, if you look at this one right here, okay, our k now is 7.5. So 7.5, I plug that in for k, equals body length divided by forearm length. Well, if I solve so I don't have that ratio anymore, I get this equation. Body length equals our constant variation, 7.5, times f. Now, you didn't necessarily need to solve it like this again, because look right here. We had already written this out, and once you find your k, you can just substitute it in, just like if it was x's and y's. Okay? So our direct variation model is going to be body length equals 7.5 times our forearm length. Now, this is based on real life data. So again, we're going to estimate. It says estimate the body length person whose forearm length is 10 inches. Well, what we can do is we take our equation, our direct variation equation, and say body length equals 7.5 times our forearm length. We plug in 10 for forearm length, and you just multiply 7.5 times 10 to get 75 inches. Is that exact? Well, not exact, but it's probably a very good estimation, because what we did is we took real life examples, okay, and from them found our constant of variation, and then created our created our direct variation model so we can make predictions on what's going to happen in the future.